In 10.3, we got our first little glimpse into exponential functions, and we talked about comparing models between linear, quadratic, and exponential, and we spent a lot of time first semester graphing and analyzing linear functions, and a lot of time this semester looking at quadratic functions. So what we're going to do for the rest of this unit is we're really going to analyze exponential functions. So today the focus is going to be about how do we graph an exponential function? What makes it special? What do we need to keep in mind when we're graphing? And we talked about some of the characteristics of the graph of an exponential function in the last section, but we're going to make sure we hit all of those points again today. So our essential question for 10.4, how do we graph exponential functions? So we want to start by making sure we remember what an exponential function is. An exponential function is of the form f of x, or y, equals a times b to the power of x. So the key thing here is that the exponent is the variable. The exponent is the variable, or the variable is in the exponent. And in future classes, you will analyze exponential functions in a lot of different ways, but the key, we're going to focus on just really the basic form of a standard exponential function here. So some things to note, we talked about this already. A is not 0. If A was 0, 0 times bx, we wouldn't have anything here. B is not 1 because 1 to the power of anything is still just 1, which would make it not an exponential function either. And our b value is greater than 0. So exponential functions, we remember from last class, have graphs that kind of look like a skateboarding slope or a skiing slope. So keep that shape in mind when we are graphing. A couple of other things to graph or to consider when we are graphing is that each of these exponential functions are going to approach a horizontal line called an asymptote. So again, each of these exponential functions will approach a horizontal line called an asymptote, and we need to make sure that we don't cross it. We also need to make sure that it's on our graph when we are actually graphing it. So here's how we graph exponential functions. The very first thing we're going to do, just like when we start graphing any function, is we're actually going to just pick some values that we want to plug in for x. And unless there's a fraction that in some way is going to make different numbers easier, I'm going to recommend that you always choose the numbers -2, -1, 0, 1, and 2. We want to, and we're just choosing those numbers, create a table, pick values of x. So you should include positive and negative numbers in your graph or in your table of values. Then we're going to plug these in, and we're going to have to remember some rules of exponents here from way back in Unit 7. So I'm going to actually show my work down here for the table. If x is equal to -2, then I'm saying 2 to the power of -2. And remember, with negative exponents, we take the reciprocal and make the exponent positive. So this is 1 over 2 squared, which is 1 over 4. So when we plug in -2, we get 1/4. When we plug in -1, we have 2 to the -1st power, which means we need to take the reciprocal and make that exponent positive, which just gives us 1/2. When we plug in 0, anything to the power of 0 is 1, so we're just going to get 1. When we plug in +1, we're getting 2 to the 1st power, which is 2. And when we plug in, I need another color here. When we plug in 2, we get 2 to the 2nd power, which is 2 times 2, which is 4. So the first thing we're going to do, make that table, choose the values of x. Most of the time, these 5 x values are going to be perfect for what we're trying to do. Once you have done that, you're going to plug in those x values like we just did to solve for the different y values. So now we have a bunch of ordered pairs in a table, so we need to make a graph. You'll notice this graph doesn't have axes, and most of the time we give you axes, but on these ones we don't, because you need to figure out where you need to put them. So something to notice, all of our y values are positive, and they're growing in kind of a small way, and our x values are both positive and negative. So I probably want the y-axis to go right down the middle vertically, but I want the x-axis to be pretty low to the bottom. So now I have my axes drawn here. And what I'm going to do next is I want to figure out how I want my scale factor to go. So if I have the x-axis just go by ones, this is going to be kind of squished together. If I'm looking at, if I have this be 1 and this be 2, my graph is just going to be squished right here, which is going to be hard to see. So instead what I'm going to do is I'm going to make every line 1/2. So this is going to be 1, and over here this will be 2, just so that it's spaced out. You could even go over 3 and do every 3 lines or every 4 lines, but I'm just going to do every 2. So what I mean by that is right here, this is -1, and right here, this is -2. This is +1, and this is +2. And I'm actually going to come underneath my graph, and I'm going to say x scale is 1/2. Because I'm going to scale my y values differently. My y values are going from +1/4 up to 4. And since graphing fractions can be really stressful, what I'm actually going to do is make every line on my y-axis be 1/4. Because then each of these y values that I have to graph will actually be on a point, or on where 2 of these little lines cross. So this is 1/4, 1/2, 3/4, 1. 1 1/4, 1 2/4, 1 3/4, 2. 1, 2, 3, 4, 3. 1, 2, 3, 4, 4. And I'm just going to number the integer values so that I'm not just kind of making a messy graph here. And I'm going to use the colors that I used in the table to graph the points so you can see each individual point. So -2 1/4 is actually just going to be right here. -1 1/2, so that's going to be right here. Since my graph is moving up by 1/2, 1/2 is 2/4. 0, 1 is going to be right here. 1, 2 is going to be right here. And you'll notice it's starting to curve up, right? These are our skateboard ramp-like graphs. And then 2, 4 is going to be over here. Now, a couple of things to consider. Something that I absolutely want you to do is I want you to have your asymptote on your graph. And your asymptote for every problem that we're going to do is going to be the x-axis. It's going to be the line y = 0. And I want that to be a dotted line on your graph, because it reminds you and it reminds me that your graph should not touch or cross that line. No matter what number you plug into this function here, whether it's -1,000,000 or 5, you're not going to get a negative value, because what happens if we plug in a negative value? We get a negative exponent, which we saw down here still gives us a positive number. So our output, or our y value, is never going to be negative, and it's never going to be 0. It's just going to keep getting closer and closer and closer to 0. So we created our table, we picked our positive and negative x values, we plugged in those positive and negative x values to find our y values, we plotted the points. Now we need to connect. When you connect, remember that your graph is a curve. It's not a straight line, it's not a quadratic, it's a curve, and it should have that sort of sloping shape. Also remember that you should not cross that asymptote. That is why we are graphing it. So go ahead and do the best you can to connect those dots, and be aware of sort of where your graph is exiting the function. And I know this is going to be hard digitally for me, so I know it'll probably be hard for you in Go Formative. Much easier on paper, but do the best that you can to try and make this look like one fluid curve. All right, I'm going to try that again. All right, that's a little better. Make sure your graph has arrows on the ends, and make sure this end is going up towards infinity and this end is getting closer and closer and closer, but not crossing the x-axis. Now, if I asked you about the domain and range here, and this is going to be pretty much the same for all of the problems that we are looking at here. The domain, and remember, is talking about our x's. What's happening with our x's? Are we allowed to plug in negative numbers? Yes. So it's going down to -infinity. Can we plug in 0? Can we plug in positive numbers? Yes. The domain is going forever left and forever right. So that's going to be all real numbers, or -infinity to +infinity. Now, what about the range? It's not going down forever, because keep in mind what's happening at our vertical, or at our horizontal asymptote. So it's going down to 0, and it's never actually getting to 0, which is why we're going to have parentheses with that 0. Then what's happening on the upper end, it's going up forever, so it's going up to infinity. So here is our domain and our range for this graph that the function that we just graphed. And that's really all we're going to do. We're going to practice this 3 more times, making our table, choosing our x values, plugging them in to find our y values, sketching our curve with our asymptote, and then identifying the domain and range. We're going to practice that whole process 3 more times. All right, so here we go. I'm creating an xy table for the exponential function y equals 1/2 times 2 to the x. And remember, just like with a geometric sequence, we can't multiply these. That violates the order of operation. So I made my table. I'm going to pick my x values. I'm going to pick the same 5 x values that I picked last time, -2, -1, 0, 1, and 2. And then I'm going to do the work for each of those values. So first, I'm going to plug in x equals -2. And when x equals -2, we have 1/2 times 2 to the -2nd power, which is 1/2 times 1/2 squared, which is 1/4. 1/2 times 1/4. Remember, when you're multiplying with fractions, you multiply across the top and across the bottom. So that's going to give me 1/8. When I plug in -1, so if x equals -1, then I'm looking at 1/2 times 2 to the -1st power, which is going to be 1/2 times 1/2. Again, multiply across the top to get 1, across the bottom to get 4, and we get 1/4. If I plug in 0, if x equals 0, we have 1/2 times 2 to the power of 0. Anything to the power of 0 is 1, so that's going to be 1/2 times 1, which is just going to be 1/2. If I plug in 1, I'm going to come down below to do this work here. If x equals 1, I have 1/2 times 2 to the 1st power, which is 1/2 times 2 over 1. Across the top and across the bottom gives me 2 over 2, which is just 1. And then last but not least, if I plug in 2, I get 1/2 times 2 squared, which is 1/2 of 4, and half of 4 is 2. So again, looking at those x values, I'm going to want the y-axis to be right in the middle so that I have a good amount of space on the left and the right of my graph. My y-axis, the biggest it goes up is 2, and if I want to try and make my fraction graphing life easier, I think I'm going to have my y-axis go by 1/8, each line being 1/8. So I'm going to go ahead and plot or create my axes here first. Now I want to think about my scale factor. I'm going to use the same scale factor for x that I used before. So I'm going to have my x's go by 1/2. And I'm going to just make a note of that off to the side. X scale 1/2. Y scale. I'm going to make my y values go by 1/8. So every 8 lines, 1, 2, 3, 4, I'm going to tell myself that's 1/2. 5, 6, 7, 8, that's 1. 1, 2, 3, 4, that's 1.5. 5, 6, 7, 8, that's 2. That way I don't have to try and graph any fractions. And then I want to remind myself that this graph is never going to cross the x-axis. So I'm going to graph my asymptote, which is y equals 0. All right, now let's go ahead and graph each of those points. -2, 1/8 would be right here. -1, 1/4 would be up at this, oops, not at 1/2, silly me. 1/4 would be 2/8, so right there. 0, 1/2. 1, 1. Nope, I moved that too far over. There we go. 1, 1, and 2, 2. And then when you connect, make sure it looks like a curve. Make sure it's getting closer and closer and closer to that dotted yellow line, and then it's going up to infinity on the top of the graph. Make sure your graph has arrows on the ends. All right, our domain is still -infinity to infinity. There is no x value that we aren't allowed to plug in. Our range, Well, it's going down to 0. It's getting closer and closer and closer to 0, but never actually getting there. So parentheses with 0, and then it's going up to infinity off the top of the graph. So now we have our domain and range. So why don't you go ahead and pause the video, set up your table for number 2, plug in those values, and see if you can just find each of the values that go in the table, and then unpause the video and see how you did. Okay, if x is negative 2, 1/4 to the negative second power is 4 to the second power, which is 16. Negative 1/4 to the negative first power is just going to be 4. We're just going to take that reciprocal. 1/4 if x is 0 to the power of 0 is 1. If x is 1, 1/4 to the first power is 1/4. And if x is 2, 1/4 squared is 1 squared over 4 squared, which is 1 over 16. So again, my axes are going to look really similar to how they looked on number 1. And my y-axis, I think I'm going to go by ones, even though I know I'm going to have to graph 1/4 and 1/16. I want to get all the way up to positive 16, so I'm going to have my y-axis go by ones and my x-axis go by 1/2. So go ahead and pause the video and set up your graph. Okay, so my graph is set up now, and I'm going to go ahead and plot those points. Negative 216 is going to be right here. Negative 1/4 is going to be right here. 0, 1 is going to be down here. Oops, that didn't change color. 0, 1 is going to be down here. And then when I get to these fractions, I just want to make sure I'm getting smaller. So I know that I'm graphing 1/1/4. That's just going to be somewhere there. And then when I graph 2 and 1 over 16, I want to make sure that that's getting a little bit lower. I'm going to go ahead and add my horizontal asymptote, this y equals 0 dotted line that my graph should never touch. And then I'm going to connect, and now this smooth curve is actually going to go from it's going to go sloping downwards. So go ahead and connect those dots. Make sure you don't cross that asymptote. And there you go. Number 3 is going to have some fractions because we have the 1/3. It's not going to be too big of a deal. We're just going to have to graph a couple of fractions, which I know gives us all a little anxiety, but we're going to make it through together. Oh, let's go ahead and identify our domain and range on number 2. That domain is still going to be all real numbers. And that range, even though this looks different, you're always asking yourself high, low. What's the lowest the graph is ever going? The lowest it's ever going is 0, and it never actually gets there. And then even though it's flipped from the ones we've been looking at, it's still going up forever towards infinity, so the range is still going to be from 0 to infinity. All right, on to number 3. Go ahead and set up your table, pause the video, and see if you can just fill in all the values for the table on your own first. All right, if x equals negative 2 times 1/3 to the negative second power. So remember that negative second power means we're going to take the reciprocal and make that exponent positive. So this is negative 2 times 3 squared, which is 9, times negative 2, which is negative 18. And then if we look at the next value, if we plug in negative 1, if x equals negative 1, negative 2 times 1/3 to the negative first power is going to be negative 2 times 3, which is negative 6. If we plug in 0, if x equals 0, we have negative 2 times 1/3 to the power of 0, which is negative 2 times 1, which is going to be negative 2. If we plug in 1, we're going to have negative 2 times 1/3 to the first power, which is just going to be negative 2 times 1/3, or negative 2/3. And then last but not least, if x equals positive 2, I have negative 2 times 1/3 squared, negative 2 times 1/9, which is just going to be negative 2, over 9. So something different to notice on this problem, all of our y values are negative. So instead of having our x-axis be at the bottom of the graph, how it's been before, we're actually going to want it to be up here towards the top of the graph. So now I have my axes. I'm going to make my x scale factor still go by 1/2, and I'm going to make my y scale factor go by 1s, just so that I can fit all the way down to -18. So here I've added some information onto my graph so that I can plot those points. So -2, -18 is going to be way down here. And then -1, -6 is going to be up here. 0, -2. 1, -2/3, which I know it's a fraction. I'm not going to get it exactly. I'm just going to make it right about there. And then -2/9 should be smaller, so I should be getting closer to the axes because remember, my graph is approaching this asymptote at y equals 0. So now I'm going to go ahead and connect that curve and then identify the domain and range. So there's connecting the points. The domain, again, I can plug in any x value. It's going forever to the left and forever to the right. And the range, remember, we're always asking ourselves, what is the smallest it goes and the biggest it goes? So the smallest it goes, it's actually going down forever. So that's -infinity. The biggest it ever goes is up to the x-axis, which is 0. And again, we still have parentheses there. So the range, the domain is pretty much going to be -infinity to infinity on every problem that we're graphing here. But the range could actually be going down forever instead of up forever. So make sure you're asking yourself about the highest and the lowest points for your domain and range. So graphing exponential functions, make that table, choose the 5 points, plug them in, make sure you graph your asymptote at y equals 0, the line that your curve is never going to touch, and then identifying the domain, looking at those x values, and the range, looking at those y values. Make sure you write down any questions you have. I look forward to supporting you on this in class. Thanks for listening.